Hey everybody, this is Professor Ross here to talk about fraction division and helping students learn to divide fractions. Just as we've seen with a lot of our other computations, there's a lot of value in allowing students to invent strategies before coming to the traditional algorithm for dividing fractions. The traditional algorithm calls for students to invert the second fraction and multiply. It may be one of the least understood algorithms that we use for computation. You could even ask a lot of teachers who teach students to do that, why do we invert and multiply? And they couldn't give you a good reason. So we want to talk a little bit about trying to build rather on understanding of what the fractions mean, and also the understanding of what the operation division means. We also want to use a variety of models with students so they can build deep understanding. And also I want to encourage you to consider teaching students an alternate algorithm that uses common denominators that is a lot closer connected to meaning. So let's talk about a couple of types of problems here and see how the two algorithms look and see how they can connect to meaning of both division and fractions. Let's say we've got a baker who has 6 cups of flour remaining. Each loaf of bread calls for 3/2 cups of flour. How many loaves of bread can she make? All right, and here I've got a picture of 6 cups of flour, and we got to try to figure out how many loaves of bread she can make. Why is this division? Well, what does division mean? Division means you take something and you divide it into equal parts. Here we've got 6 cups, and we're trying to divide it into equal parts that are each 3/2 cups big. So it's the same meaning for division as always. We have to understand what 3/2 cups, 3/2 of a cup of flour is, and so we need to know what 1/2 of a cup of flour is. And if I've got 6 here, if I split them each into 2 parts, then they're each split into halves. So if each loaf of bread calls for 3/2 cups, I just want to take 3 of those, and that's 1 loaf. And here would be another loaf, and here would be a 3rd loaf, and here would be a 4th loaf. And so she can make 4 loaves of bread out of her 6 cups of flour. So pretty straightforward to see from the drawing. How does that connect to the algorithms? Well, first let's talk about the quote-unquote traditional one. 6 divided by 3/2, we say we can compute by doing 6 times 2/3. And how do we do that? Well, we think about it as 6 over 1. 6 times 2 is 12/3, and 12/3 is the same as 4. What does this 6 over 1 times 2/3, how does that connect to any meaning here? It's very, very difficult to see any connection to meaning in what we looked at over here. Alternatively, if we use an alternate algorithm using common denominators, we'll see that it connects very closely to what we did here. What do I mean, use common denominators in an alternate algorithm? Well, instead of doing 6 over 1 divided by 3/2, we would realize that 6 over 1 is the same as 12 over 2, or 12/2. 6 wholes is the same as 12/2. And now the question is, okay, if I've got 12/2 and I'm splitting them into groups of 3/2 each, how many groups do I have? Well, here are my 12/2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'm just grouping them into groups of 3. That's exactly what I did. And we can see that I ended up with 4 of them. When we get a common denominator, the problem becomes a question of what's happening with the numerators. I had 12 of these things, I split them into groups of 3 of these things, and I ended up with 4 of these things. It simplifies the problem, and actually in this case makes it a whole number division problem, which students already know how to do. All right, so we can do division with a whole number and fractions. We can also do division with fractions and fractions. So things are a little more challenging here to understand conceptually what's going on, but with a good context and some illustrations, we can really make a lot of sense of this. So let's take a look at number 2 here. The baker has 3/4 cup of sugar remaining. Each batch of cookies calls for 1/3 cup of sugar. How many batches can he make? So I've got a picture over here. This is a cup split into fourths. So if he's got 3/4, then this part's already gone. And he's got this 3/4 left here. Each batch calls for 1/3 cup of sugar. So now the question is, okay, if I'm going to take this whole cup and take 1/3 of it, it's going to be, somewhere in here, right? And that would be one batch of cookies here. And then there's going to be another third in here somewhere, right? And that'll be another. It looks like I'm going to be able to make more than 2, but how much more is hard to say from a picture like this. So we need to kind of think again how we might approach this thing here and figure out what's going on. And here's where the traditional algorithm is not very informative. It would say take 3/4 divided by 1/3. That's the same as 3/4 times 3/1, and you'd have 9/4. But that doesn't really help us understand much about what's going on over here. Instead, I encourage you to think about this. I can take 3/4 divided by 1/3, and if I can frame that in terms of a common denominator, it can make a lot more sense. A common denominator would be, for example, 12. So 3/4 is how many twelfths? It would be 9/12. And 1/3 is how many twelfths? That would be 4/12. And now I'm simply saying I've got 9 of something and I want to put it into groups of 4. And I'll have 9/4. What does that mean up here? Essentially, I'm saying 3/4 is 9/12. If I take this thing, and much like in multiplication, when we split the opposite direction, we can split this thing here and see that I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces here. And how big are they? Well, the whole thing is split into 12 pieces, so that's 9/12. And that's exactly what we mean when we say 3/4 is the same as 9/12. I want to now group them into groups of 4/12. Why? Because 4/12 is 1/3. Like if I took this whole vertical column, I'd have 4/12. Of course, I don't have this top piece here, so I got to take 4 in a group, something like this. I could take any 4 I want, but there's one group I could make. Here's another group of 4 I could make, and then I'm left with 1 left over. So my answer here would be 2 and 1 of it's 1/4 of a group, right? Each group is made up of 4 pieces, and that's 1. Is 2 1/4 the same as 9/4? Indeed it is, because 2 is 2, each of those is made up of 4/4, so that'd be 8/4 plus 1 more is 9/4. So we came to the same answer, but in a more meaningful way. So this alternate algorithm using common denominators can help us understand a little bit better about what's going on. It's also pretty easy to do the computation once you have the common denominators. You essentially just ignore them and do numerator divided by numerator and get yourself your answer. So hopefully those are some helpful thoughts for you to teach students how to divide fractions.